complicated to begin with. I could divide again by a number, right? As long as I divide the entirety of one line. So for example, I could divide the first line by 7 and make it 1 over 21 plus 1 over 42 plus 2 over 21z equals negative 1/7, right? Does that change the values of the answer? No, it doesn't, but it makes it worse. Think of it in inverse. How are we going to clean this up? What's it? We should multiply each one by something to do what? Get rid of the fractions. At a minimum, it makes it easier to write. At a minimum, it makes it easier to write. At a minimum. So let's do that right now. The first equation. Who wants to tell me what I should multiply the first equation by? Raise your hand. Alex, what should I multiply the first equation by?
6.
Let's multiply the entire thing by 6. If we multiply it by 6, we end up with 2x plus y minus 4z is equal to what? Negative 6. Great. What should I multiply the next one by? Someone else, someone different. Tell me. What should I multiply the next one by? Milo. 12 is a perfect. Perfect. If I multiply that by 12, I end up with negative what? Negative 9x minus 4y minus what? 3z is equal to what? Is equal to 36. And then someone else tell me, what should I multiply the next one by? Connor. Yes? Sounds great. If I do that, I end up with, can someone read me what I get? Connor, can you tell me what I get? 2x. Yep.
Plus 6.
Yep.
Y.
Yep.
Plus 3.
Yeah.
Z.
Equals.
24.
Careful.
Equals 84.
84. Excellent. Excellent. So now, have we changed the overall value of the answer to this system? The solution to this system? No, we haven't. But what have we gotten rid of? Technically, fractions are there because everything over 1 is a fraction, but you're absolutely correct. We've gotten rid of any sort of annoying fraction. We've traded that for larger numbers. Generally speaking, what are we more okay with, larger numbers or fractions? Yeah, we kind of like larger numbers a little bit. We kind of do, because you can always simplify them at the end, as opposed to working with nasty fractions all throughout the work. Okay. What do we do next? One word. What should we do next? One word. Isolate. Excellent. Nick, which one should we isolate? I love y in the first one. Excellent. Why did you pick y in the first one? It's pretty much already isolated, exactly. So what's it going to be? Negative 2x plus 4z minus 6. What's the next word? What's that next word? Isolate and then substitute. So if we now substitute, where do we substitute this? The other two equations. And if we substitute into those two equations, it'll with negative 9x minus 4. But instead of y, what do we write? Negative 2x plus 4z minus 6 minus 3z equals 36. And then we end up with 2x plus 6 times negative 2x plus 4z minus 6 plus what? Equals, oh, did I just combine that? Did I write that right? Yeah, I did write it right. Okay, equals 84. Ooh, okay. Did I substitute that okay? What do we think? How does that substitution look? Double check it for me. It looks okay. Looks okay. So, can someone tell me how many variables do we now have in this? We have 2. How many equations do we have? We do have 2. So are we in the land of happiness and ponies and rainbows? We're pretty much there. We're pretty much there. One word for what we should do next. Simplify. Yeah, we're going to distribute because we need to simplify. So if we simplify this, what form are we looking to get these into? Which form do we like? We like standard form. You combine, you distribute, combine like terms, clean it up. And then when we're done, we're going to end up with values for x. And we're going to end up with values for z. But then once we get values for x and z, what are those going to lead you to? The value for y. Absolutely. We're not going to finish this one, but do you feel pretty comfortable with how we got to right here?
Yeah.
Good. Good. First worked with what kind of systems? Not 3x3 systems. We worked with 2x2 systems. Let me do that again. So we did 2x2 systems right here. And then we stepped back And we started with what? 3x3 systems. And what did we do? We turned our 3x3 systems into 2x2 systems. So we got back to the land of happy now. Now, we stepped back a little bit yesterday. We haven't done this quite yet with a huge example. But instead of starting with a set of 3 equations for a 3x3 system, what could we start with instead? Instead of starting with equations, we could start with what? What's an alternative way to write an equation?
Expression.
An expression with what? Words.
So words.
Are there word problems that lead directly to a 2x2? Absolutely. Are there word problems that give you a... We've done those before. Are there going to be word problems that lead us to a 3x3 system? Yes. But once we get a 3x3 system, what's our goal? Our goal is to turn the 3x3 into a 2x2 and then solve it. We've done this before. We have definitely done taking a word problem and turning it into a 2x2 system. The mechanisms, reading, the comprehension, labeling variables, is that going to change when we go and start working with 3x3 word problems? No. The mechanism is going to be the same. The only thing that changes is that instead of working with 2 variables, we're going to work with 3. We need to check to see how well you can handle 2 variable system word problems. So please put everything away except a pencil. Could have written down something like this. T equals the rate of truck.
Yep.
C equals rate of car, correct? You know that distance equals what? Rate times time, correct? You know that 250 is how far the car goes in the same amount of time the truck goes, 225. So 250 is the distance the car travels. How fast is the car traveling? C, the rate of the car. Rate times some time. You don't know how much it is, but it's some time. You also know that 225 is equal to T, the rate of the... That's another rate right there, the rate of the truck. They're both rates. Times what? Time. You don't know, but it's the same amount of time. It says that it's the same amount of time. Can you isolate time in the top one? If I wanted to isolate time right here, how do I isolate time?
Subtract the rate.
Nope.
Divide.
Divide by C. You know that time is equal to what? 250 over C. What about this one? Can you isolate time? Time is equal to what? Over T. You know that time is equal to 250 over C, and you know that time is equal to 225 over... Don't erase. Oh, yeah, you need to see it. Go ahead. Yeah, go ahead. Sure. Sorry. Just some of it. I'll finish it right now. You know that these two things have to be what? Equal. So what relationship do we now have? 250 over C is equal to 225 over T. There's your second relationship. Go. Finish. 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 You know that the first equation, it was H is equal to what? 3S. 3S. And you know that F is equal to what? H minus 5. And then you had the total cost equation, which was 2.95 times H plus 2.99 times what? What was that cost? S plus, what was the... That's expensive French bread. I grew up in a bakery, so yeah, that is actually a little expensive, I think. 87 point what?
89.
Okay, so you have 3 equations. It looks a little challenging. I want to show you a shortcut on this one, and I'll try to use a different color for my next line here. Right here, you know what H is equal to, correct? H in terms of S. Do you have an H in the second one as well?
Yeah.
You have an H in the second one. So theoretically, what does, not theoretically, I can just ask you in concrete terms, on this one right here, what does, oh, you already have F. Let's just put that in there. Theoretically, could I take this and march it down right here?
Yes.
Absolutely. Oh, okay, what about this one? Can someone tell me what S is equal to? What does S equal on that top one? h over 3. Where could I substitute that? For s. If I did this substitution, you end up with 2.95h plus 2.99. Instead of s, what am I writing? H over 3 plus 5.79 times, oh, what does f equal? Equals 87.89. How many variables are in this? 1. So what could you solve for now? You can now get h. And once you get h, what can you find? S and f. So this was a shortcut that you can recognize if you have enough practice, but theoretically, could you do the same thing we've done in the other ones? Absolutely. Absolutely. Now, if I gave you a question like this, what could you expect to have access to? Yeah, this would be kind of annoying to do without a calculator in ways that I don't want the question. Sometimes I do want to annoy you a little bit to get you to think out of the box and be a little creative, but do I really want you to have to deal with like fractional sense as an, not really. Use your calculator. Yeah?
Couldn't you just solve an h, like instead of putting it over 3, just put it in 3s?
If you did that, you could, but if you did that, you would have multiple variables in this expression. You want to get rid of everything except for h. You just want h. Yes, you can say h is equal to 3s, but then you have s, h, and h. You just want, how many variables do you want?
1.
You'd love
but
1.
You get there eventually.
You could, but what I'm saying is, you can get there right now. So I'm trying to show you some of the direct methods that are helpful in solving these and making your life a little easier. So just because you have one tool doesn't mean that you're going to use the hammer over and over and over and over again. Try to think, be a little flexible. Okay.